Hello. So today we are going over homework question 4.4. So for part A, here's a box of books. The mass of it is 61 kilogram, and the floor is freshly waxed, so we ignoring the friction, and we have the applied horizontal force of 25 Newton. So here's the applied force applied. So this is the mass, and it's 25 Newton. And the question asks us for the acceleration in the box. So we know the function of force is F. Force equals to the mass times the acceleration. So if we want the acceleration equals to the force divided by the mass. So we know the force is 25 Newton and the mass is 61 kilogram. So that gives us the acceleration of the box is 0.41 meter per square second. For part B, here's the block of cheese of mass 1.8 kilogram. So here's the cheese, the mass, right on the side. So the mass is 1.8 kilogram. And the question, and we apply a constant horizontal forces of 0.5 Newton to the cheese. So here is the applied force. Applied force of 0.5 Newton, and it asks for the 3 external forces that act on the cheese. So the first we have the applied force, and then since it's on the level, we have the normal force and the weight, mg. So here are the three. Here's the 3 external force on the cheese. So let's go part C. Part C is to determine the directions of these forces. So the applied force should be directly horizontally along the acceleration of the cheese. So horizontally along the cheese. And the normal force is vertically upward, since it's less on the surface. Upward. And the weight is vertically downward towards the earth. And part D, as for the acceleration again, so again we have the formula of force is force equals to the mass times acceleration. So acceleration equals to the force divided by the mass. So we have the force of 0.5 Newton, and the mass of the cheese is 1.8 kilogram. Now we do the calculation. It gives us the acceleration is 0.28 meters per square second. So part E. So we have the ice hockey. You use a hockey stick to hit a puck of mass 0.16 kilograms. So here, draw here. Here is the ice hockey. So we have the applied force of since it says it's yeah, 0, this is applied force is 0.16 kilogram. And during the hit, you exert the constant horizontal force of the puck, give an acceleration of 75 meters per square second. So it's the same direction of the applied force, is 75 meters per square second is the acceleration. So, and they ask for the magnitude of the horizontal force. So again, we have the formula: force equals to mass times the acceleration. And so we have the mass of 0.16 kilogram, and the acceleration equals to 75 meters per square second. And that gives us the force is 12 Newton. And for part F, how does the magnitude of the normal force N due to the S compared to the weight W of the puck? Since here's the surface, here's the surface, and here's the S hockey, and this normal force, and this is the weight. And since the S hockey lies on the surface and doesn't have vertical movement, so the normal force N should equals to the mass of mg of the puck, yeah. And for part EFG, for part G, we have the this plate of food, and I push it away from me with the constant horizontal force of 14 Newton. So this the force applied is 14 Newton. And the plate has a mass of 0.52. So here's the weight, 0.52 kilogram. And during the push, the acceleration gives an acceleration of 12 meters per square second. So along the applied force, the acceleration is 12 meters per square second. And part G asked us for the net external force on the plate. So the force equals to the mass of the plate times the acceleration, which gives us 0.52 kilogram times 12 meter per square second. And after the calculation, we have 6.24 Newton. So that's the net external force on the plate. And for part H, yes, what are the magnitude of and direction of the friction point that the table acted on the blah 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 blah. Oh, sorry. So here we change the letter to R since that's the question gives us. So the net force equals to F applied force plus, wait, 1 second. Let me see, what's wrong? That's the, oh yeah, sorry. So the net force equals to the applied force of the external force plus the friction. So the friction equals to the, wait. Oh, yeah. So the net external force, sorry. So here's the friction, so F applied, so 6.24 Newton equals to, so this the F net goes to the R equals to the applied force plus the friction, so all the external force plus together. So we have the net force of 6.24 and the applied force is 14 Newton plus friction. So friction equals to 6.24 Newton minus 14 Newton, and that gives us negative 7.76 Newton. And this is correct because the friction is if we set the applied force as positive direction, so the friction is opposite to the applied force, which is negative. So this is the correct answer. It's negative 7.76. And thank you.